In this lesson, we will be looking at section 4.5, which is solving percent problems using the proportion P over 100 equals A over B. The proportion P over 100 equals A over B can be used when solving percent problems. The variables P represent percent, A represents the amount, and B represents the base. For the proportion A over B, the amount over the base, let's take a look at what those numbers represent. As we can see, A is the numerator, or the top of the fraction, and that number represents the part of the whole. So it is the amount the word problem is concerned with. And then the letter B, or the base, is the denominator of the fraction. And so it is the amount that makes up that whole. And we'll look at some examples. So if this is a little confusing, hopefully it'll make more sense to you. When setting up a proportion to solve a percent problem, it's important to read the problem carefully. Make sure you look at and determine which values in the proportion are the known and which values are unknown. So again, we had three variables in this setup: the P for the percent, the A for the amount, and the B for the base. Any one of those could be the unknown number in the problem. At the beginning of the workbook, there are some steps that can be taken when looking at any sort of problem, and so let's just mention those here. For step 1, you're going to read the problem. And I like to read the problem one time just to get the overall idea, and then start reading it slowly, dissecting it apart and seeing what I need to do for it. And so for these problems, what we need to do for it would be step 2, writing the percent proportion with the known variables. Step 3 then would be to solve that proportion. And then step 4 is a common step that a lot of authors and teachers say to check your answer. So obviously that's optional, but a lot of times just kind of thinking about the problem will help you determine whether your answer makes sense or not. And the page where all this information was on was page Roman numeral 18. And this is just what that page looks like in the front of your book if you want to turn to it and read through it. So being able to identify the important information in a word problem is something that it just takes time and practice to do. And so again, we have the amount, the base, and the percent that are going to be pulled out of the story problem. And 2 of those we will be given enough information to plug in, and there's the third one that they'll be asking us to solve for. And so let's go through some examples where we're looking at that and identifying those 3 pieces. Our first example is 45% of what number is 36. And so for this one, our percent is easy to locate. We can see that up front, and so that is 45%. And so we need to figure out what is the amount, what is the piece that it's concerned about. So that 45% value would be the amount, and the base would be out of how many total. And so we need to figure out if 36 represents the amount or if it represents the base. Now we can use the wording to help us with this. We have 45%, and see the word is means equals to. And so the 45% is the 36. So that's the amount that it's concerning with. And so the 36 is the amount, is our A. And so let's put that here. And so our base is our unknown. And so it is. So we're going to use our letter B for our base. And so to write this proportion problem, we are going to say that we have our 45, our percent. And again, it's out of 100. We know percent means of 100. That's how we write it for our proportion. And that's the same amount as 36 is out of the total amount we don't know, the base. And we've already learned how to solve these problems, and we'll have practice solving them in a little bit. It's not asking us to solve this one. Again, it's just trying to help us learn how to take information out of a sentence problem or a story problem and set up that proportion that would be solved. Let's take another look at a problem. During the past year, Franklin spent 32% of his income on his mortgage and home repairs. If he earned $38,750 during the year, how much money did he spend on his mortgage and home repairs? So just like the last problem, the percent is easy to identify. We can see that 32% right there. And so, oops, our percent is our 32. So again, 32, we can read from the story problem, represents his mortgage and income costs. And so this represents mortgage and home repairs. And the question is, how much did he spend on the mortgage and home repairs? And so that tells us that that's the unknown value. That's what we're going to determine from our proportion. And so let's put that our amount, our A value is our unknown. And so the base then would be the total amount of money that they make for the year. And so $38,750 is not how much he spends on his mortgage and home repairs. It's how much he earns for the entire year. So that's our base. So 38,750. So now we know those three pieces that plug into our proportion problem. So let's go ahead and do that now. We have 32%, so 32 out of 100 is the same proportion as our unknown value that represents our mortgage and home repairs costs out of the total, which was our 38,750. So there's the proportion that can be solved for this problem. Another example, Tilda purchased a pair of jeans that cost $48. The cost of the tax on her purchase was $4.08. What percent of the purchase price was the tax rate? So looking at this, I don't see a number with a percent sign. So that's going to be our unknown, and we can see that in the question, what percent? Here. So that's telling us that our percent is our unknown value. And so P represents our percent in the proportion. So what is that amount? So the amount is the tax rate. And again, if we go back to the wording, the percent was is another form of is the tax rate. And so the tax rate is $4.08. So that's going to be the amount, the smaller amount of the total purchase cost of $48 being how much that she's paying in tax. So let's add our 4.08 for our amount. And so the base, it's based on the cost of the jeans. And so our base amount is 48. And so now we have all our pieces identified, so we can write our proportion, P over 100 is the same amount as 4.08 compared to 48. So here's a couple problems that are for you to set up and solve. So again, you can pause this, take some time to work out these questions. The answers for that is under your answer key, which is on your Files tab under Canvas, if you'd like to look them up. So take a few minutes and pause the recording, and when you're finished, go ahead and start it back up. Let's take a look at some story problems together. And it says the following problems focus on two important parts of solving percent problems using the proportion P over 100 equals A over B. The first part is setting up the proportion based on the information provided. And the second part is understanding what the answer means and putting it into words. Outside of the math course, problems which need math to solve them will often involve this type of translation into mathematical notation and back into words. So figuring out what that answer represents or what it means. And so that would be an example of, bringing in some statistics and numbers like this into a business meeting where you're explaining the numbers that you're giving the coworkers, audience. And as you can see with this case, we're using actual statistics, actual data. Here's the source. So again, it's something that has real world applications outside of just your math class. In 2011, 70.7% of babies in the state of Washington were vaccinated against hepatitis B within 3 days of birth. If 86,929 babies were born in Washington in 2011, how many babies were vaccinated with hepatitis B against hepatitis B, within 3 days of their birth? So let's set up the proportion. So again, we have two pieces that we can see here, 70.7% and 86,929. There's a couple numbers in there that are unimportant to this story problem as far as setting up a proportion. One would be the year. We see the number 2011, but again, that's referring to the year. And then 3 days birth, that number 3 there is just explaining to us what's going on. It actually doesn't have anything to do with figuring out how many babies at the vaccination. So the two pieces that we know are the 70.7% and the 86,929. So let's go ahead and set that up. Our percent will go over 100, 70.7, and we put that over 100. And then that's the same amount, and we have to figure out if 86,929 babies is the amount or the base. So if we read this again, if 86,929 babies were born in Washington in 2011, that's going to give us the total. The 70.7 represents the vaccinated, and that number isn't the vaccinated. So that is the B value, the total amount, so we put it in the denominator. 86,929. And our unknown value would be our amount. So then again, it asks us to solve. So we'll do our cross multiplication. So 100 times A is the same amount as 70.7 times 86,929. And I'm not going to show all the steps for this because it would just take too long with me trying to write with the mouse to be able to show all the work for you here. But as you know, multiply our 70.7 times 86,929, and then take that answer and divide it by 100. And it says round to the nearest whole number. And so we get A equals 61459. So 61,459. Now, even if it didn't tell you to round to the nearest whole number, again, this math is in a context, and our context is babies. When we're talking about babies, we're talking about whole numbers. You know, you wouldn't say that I have 3.2 babies in the hospital. So that's why rounding makes sense in this story problem. And so that's why they're having us go that one step further and put it back into the context of what's going on in the story problem by C. What does this answer mean? And it asks us to put it in a complete sentence. And so it means that in Washington in 2011, there were 61,459 babies vaccinated against hepatitis. Let's put Hep B within 3 days of birth. That's a very specific, detailed answer as to what that A value represents that we solved for. Let's take another look at a story problem to help practice. A family has a monthly income of $3,700 and they spend $925 per month on housing costs. What percent of their monthly income goes towards those housing costs? So again, it's asking us to set up a proportion, and we see that we have two numbers. Either one is percent, so our percent is going to be our unknown. It even says what percent there to help us. And so when we are setting up our proportion, we'll have P over 100 equals, and then we have to figure out which is the percent for the housing costs and which is the total. And so the monthly tells us the total is our 3,700, so that's going to be the total, our bottom number, or our B value for base. And so that 925 is the part of the whole that we're concerned with. So the part, again, is those housing costs. So solving this, we have our P across from 3,700 and our 100 times 925. So we have 3,700 P equals, and multiplying by 100 makes it easy, so we can just put our 925 with 2 zeros to show that multiplication. And then when we divide 92,500 by 3,700, we get 25%. So again, P equals 25. It doesn't even tell us that it's a percent. I mean, we know that it's a percent because we use the letter P to represent that. But if somebody was just going to see P equals 25, they're not going to have any idea what's going on. So putting it back in the context of our story problem, our answer means that this family, we don't know who it is, so we'll say that family spends 25% of its monthly income on housing costs. Another example, let's look at the average semester tuition at a state college is $5,650. The College Board decides to raise the tuition by 7%. How much will tuition increase? So let's identify the pieces. We have the average tuition is $56.50, and we see that it's going up 7%. So those are two known values. So it's easy to start off with the percent. I'm doing 7 over 100. So again, that 7% is telling us how much is it being increased. So the 56.50 is not the amount of increase, that's the amount that it's starting off with right now. So that's going to be our base, our 56.50. And our unknown is going to be our A value on the top. And excuse my sloppy handwriting, I'm doing the best I can trying to write with a mouse. Solve for the unknown. So again, we cross multiply and we'll get 100 times A equals our 7 times 56.50. And again, I'm not going to show all the work because I don't want to take up the time of you just watching me write those numbers down. So again, 7 times 5,650, that answer divided by 100 will give us our answer. And that answer is 395.5 equals A. So again, 395.5 equals A makes no sense to anybody until we put it in context. So let's go ahead and explain what that means. The amount was a dollar amount, so let's even write it the way it's supposed to be here in our money notation. So the tuition will increase by $395, so 0.5 would be 50 cents. And then it takes this story poem a step further, and it says, what will the tuition per semester be after the tuition increase? So we have to now do a little bit more math, and the starting amount was 56.50, so we're going to add the 395.50 to that to get a new tuition rate of $6,045.50. And now we're going on even one more step further, and it says, suppose a student starts college the semester after the tuition increase. How much will a 4-year degree cost if there are no more tuition increases during those 4 years? And so it's reminding us that there's 2 semesters per school year, and we have a 4-year degree. The student obviously isn't taking summer classes like many of you do. And so we're having 8 times where we're paying tuition, 2 semesters times 4 years. And so we're going to do, let me just type it because it's a little bit quicker for me to do that and try and write it. So now we have the increased price of $6,045.50. Then we're going to multiply it by 8, and that will give us a total tuition of $48,364. Nope, it's not typing, sorry about that. So a little over $48,000 for the 4-year college degree. Let's take a look at one final story problem together. In the United States, approximately 7% of the population are military veterans. If there are approximately 22 million veterans in the United States, what is the approximate population of the United States? Again, rounding to the nearest whole number since we're dealing with people. So if we take a look at our problem, we see 7%, and again, that 7% is the same as the military veterans. And so when we look at our other number, the 22 million is veterans as well. So we know that the 22 million will be the same as our 7%. They'll both be the numerators, the top numbers for our proportion. So let's go ahead and set that up. So we have 7 over 100 equals 22 with 6 zeros. All over our unknown value, B, which again represents in this case the population of the United States. And so solving it, we will cross multiply. 7 times B equals 100 times the 22 million. So we'll have 7B equals, and so now when we multiply, we're going to have 22 with 8 zeros. And so if we divide that by 7, we will get B is, again, approximately rounded to the nearest whole number. We get 314,285,714. So again, that number by itself really has no meaning to us until we put it in the context of the story problem. So that number tells us that the approximate, and I'll just put an abbreviation for approximate, population of the U.S. is 314,285,714 people. So that is lesson 4.5. If you have any problems doing your Hawks homework for this lesson, make sure you get in contact with me so I can help you. If you're having a problem with a question, the easiest way to get that specific question to me is to screenshot it to me and send it in your email. Good luck.